Okay, so we have defined the continuous random variables. Okay, we talked about its PDF, probability density function, its connection with the CDF, the cumulative density function. So now we're ready to talk about the expectation and variance of continuous random variables. Okay, and you will see that many of the things that we have seen for the discrete random variables going to follow here. Okay, except for discrete random variables, we're doing summation, especially for expectation, right? But then here, when we're dealing with continuous random variables, we're doing integration everywhere, okay? So let me show you what we mean by that, okay? So recall that if you have a discrete random variable with PMF PX, okay, then the expected value, right, what we learned before, is that we're summing over all of the possible values of X, right? And then we're summing over the product of X, the values it can take, and then the PMF value at that point. Okay, so that's what we defined earlier for expectation of X. Okay, so this is a summation, right? Because we're working with discrete random variable. Now, if we start working with continuous random variable, okay, everything looks very similar. Okay, we have X is the value that is taking, right? Fx is the PDF function, right, of the random variable X. Okay, again, we're doing integration, okay, as opposed to a summation because now it's continuous. So this is the definition itself for the expectation. Okay, so of course, depending on what fx is, you're going to have a particular task of doing the integration. All right. Okay, so for variance and standard deviations, the definitions are still the same. Okay, so we always have the definition of variance to be the expected value of the squared distance. Okay, the square distance of random variable X to its mean. Okay, but then of course, we always work with the simplification. Okay, to get the variance of X, is equivalent of getting the expectation of the X squared, right, minus the square of the expectation. Okay, so in the discrete case, if you remember, we calculate the EX, we calculate the EX squared, right, and then from there we get the variance. So just like that, for the continuous case right now, we will have to compute expectation of X, right? We also want to compute expectation of X squared, which is a function of X, and it's a result that we're going to cover in a second. And once you get those two, you're able to get the variance. And then from there, you can take the square root to get the standard deviation. Okay, so like I said, definitions are exactly the same. Okay, the calculation detail, of course, now moves from summation to integration. All right, so for some properties, okay, so the main property that I want to cover is the expectation, right, of a function of a random variable. So back then, if we have a function of the random variable is gx, then the expectation we know for a discrete random variable is gx times px, right? And then the px is the PMF, and then we sum that over, okay? So similarly, maybe you have guessed it already. If we want to do it for the continuous random variable, okay, we are doing gx times fx. Fx is the PDF, and then we're doing integration. Okay, so this will become really handy, as you could see, that if I want to know the variance, right, if I come, yeah, I'm just write it over here. If I want to know the variance of X, right, I'm doing, by definition, X squared, expectation of X squared minus the square of the expectation. So for a continuous random variable, I will get that, right? First of all, by the definition of the expectation, and then I will use this result here as a function of, because X squared is a function of X, right? So I can use that as well to get the two terms, then I will be able to get the variance. But then of course, there could be other GX function out there that you're required to do for any kind of functions out there. All right, and a few other properties, and these are again not surprising. Okay, so if we have a similar to the discrete random variable for continuous random variable X and Y, if you want to know the sum of the two random variables, the expectation of that, it's the same as the sum of the separate expectation. Okay, we have seen that before. Okay, if A and B are constants, okay, so this result stays the same as we have seen before. The expectation of AX plus B is A times the expectation of X plus B. Okay, B is a constant, A is a constant, okay? And then again, for the variance, the effect of square, right? The constant that you multiply in front of the random variable, the effect of that on the variance is square. But then whenever you add any constant, it doesn't affect the variance at all, right? So that effect is gone. Okay, so all of those stayed the same as before. Okay, so meaning that if you already worked out the expectation of the random variable or the variance of the random variable, then if you're working with a linear, right, linear function through A and B of the random variable X, then those results could be really handy. So let's look at an example quickly. Okay, find the mean and variance of the continuous random variable X giving you the PDF. Okay, so the PDF given you is that between 0 and 1, it's 2x. Okay, it's going to be 0 otherwise. All right, so let's look at the mean. The mean, as we know, okay, is, okay, let me show that here. Okay, the mean is we're doing integration, right, of x fx dx. We can always start with the original definition, okay? And then we can go back to the next line to go into the particular context here. Okay, so the context is saying that when x is between 0 and 1, so we can immediately update the range, right, of our integration over here from negative infinity to positive infinity now to from 0 to 1, okay? And our x is still x, right? fx here is 2x, so we're doing 2x over here. So essentially we're integrating 2x squared from 0 to 1 to get the expectation, okay? And now you get the integration working, which is 2 over 3, okay? Similarly, to get the variance, just like I said, you will need to find expectation of x squared, right? So you're doing something very similar. You already found 2 over 3 is the mean, so that you take the square, and then over here looks very similar, and the overall straightforward, overall flow goes the same, okay? So again, many of the details, as you can see, that you have to take the time and then do a step by step to make sure that you are pretty comfortable with all of this, right? Especially the previous result from previous courses that you know how to do the integration, okay? Overall, like I said, you always start with the general definition, okay? And then you can narrow it down to the particular context that we're working with. And then from there, hopefully the flow is good.